For joining me. This is Adobe Fikemba, and I told you in this channel I'm going to teach you physics, chemistry, and biology. And for a while now we've been learning these different subjects, and today we're looking at chemistry. And go watch my video, chemistry part 1, 2, 3 to 10. And today we are going to be looking at the summary for separation techniques. Summary for separation techniques. Part 1 to 10 covers all the separation techniques. Go and watch it. But this is a summary to just summarize, to end it. Now, you know, with said separation technique simply means the method used, okay, in separating constituents of mixtures. This is constituents of a mixture. So the method you use in separating constituents of a mixture. A mixture is two or more constituents physically combined together and can be separated physically. A mixture, the constituent is combined in any ratio by mass. And the individual constituents makes up the mixture. They still retain their physical property. And you see it now? The sum of the individual constituent makes up the mixture, and this constituent, this individual constituent, still makes up their what? Physical. They still retain their physical property. Is that clear? So let's dive in quickly. What are the separation technique method number 1? In this thing we looked at sieving. What is sieving? Separation technique method that involves separation of solid particles with different sizes. Widely applied in garri industry, gold industry. So when you are separating solid particles with different sizes, this is the point. Hold it very well. You are practicing sieving. That's number 1. Number 2, we also looked at decantation. Decantation. This is used in separating insoluble solids. It is used in separating insoluble solids from their solution. So in this case, those solids that are more denser are found at the bottom of the container or the test tube, and those that are less denser are found at the top of the test tube. So take note, separation of insoluble solid from their solution. A modified form of decantation is called centrifugation. Centrifugation. So this centrifugation has to do with you having a machine to spin a test tube, okay, that contains a solution that you want to separate an insoluble solid in that solution. So that makes us to know from centrifugation, we deal with what we call the centrifuge. Centrifuge is a machine that spins a test tube that contains a solution at high speed. The very essence is to easily create decantation, separating the insoluble solid from the one that can be separated, which is from their solution. So the solid will be separated, and those less dense liquid parts will be found at the top. So that is what decantation is all about. And then the modified form of decantation is centrifugation. Centrifuge in centrifugation is a machine used to do what? To spin a test tube that contains solution at high speed. And for this thing to happen, the centrifuge must be what? Must be counterbalanced with equal size of test tube and equal amount of water in it, as the case may be, or what you are using to separate. Now, number 3, we also looked at filtration. Filtration. Okay, go and watch the video. The video will give you that. In filtration, it also means separating insoluble solids from their solution. But in the case of filtration, what do we do here? It involves using filter paper, okay, and the what? Funnel. Filter paper and funnel. Now, what does that mean? In this case, you have this. The filter paper is around this region. And then you have here, you have the container, you're separating it now. Now, in this filter paper and funnel, you're separating insoluble solids from their solution. As you pass through the filter paper, what happens? Only the liquid part will go through to form what we call filtrate. While the remaining particle found at the top part of the filter paper is called what? Residue. Is that clear? Go and watch the video. So this is filtrate. This one here is residue. That is filtration. Separation of insoluble solids from their solution. Number 4, we also went on and talked about evaporation. Evaporation to dryness. Evaporation to what? To dryness. It's a separation technique method. Now, what does this mean? It simply means it's a type of separation that deals with what? Removing water. Removing the liquid parts of a solution. That is removing water from the liquid part of a solution. The very essence is so that at the end of the day, we can obtain a salt or obtain a solid substance. So evaporation to dryness, it can be used to separate mixtures in which they also have a solution. Is it like a solution that when you heat that solution, okay, that's why we call it evaporation to dryness. That liquid part of the solution will what? Evaporate, escape, leaving behind the solid. But you see, this evaporation to dryness might not be the best when it has to do with some salts or substances or mixtures that can be destroyed on heating when you heat them directly. We now told you that a modified form of evaporation to dryness will be what we call steam bath method. Okay? I hope you can see. No. So steam, look at it here, steam bath method. I told you that this method has to do with what? In this case, whatever you're going to be heating, you are no longer heating the salt directly because it can be destroyed on heating. You are heating the test tube in the water. So the heat is directly hitting the water. That's why we call it steam. So it's hitting the water, and the vapor coming out from the water is hitting the test tube so that the salt will not be destroyed on heating. So that method is what? Steam bath method. But the very essence is to do what? Is to remove the liquid parts, okay, of a mixture from a solution. Is that clear? To remove the liquid part. So that when you use water in carrying out this method, modifying the evaporation to dryness, it's called what? Steam bath method. But when you use oil, okay, it is called oil bath method. We have oil bath method. Oil bath method. In this case, where you have, look at what I'm talking about, just pay attention. Look at, you have a test tube, the particle is already inside the water as a solution. Then this is it. Here is water, and here you are heating directly. Okay, so since you are heating directly, what happens? As you heat this water, the vapor that comes out to heat this will now do what? Cause the evaporation to dryness. That is because this salt can be destroyed when you heat it directly. Are you getting it now? So, but here, in this case, if the liquid used, okay, the liquid used, if it is water, is called steam bath method. But if it is, the liquid used is oil, okay, in this place is oil. When the oil is boiling or heating, it hits the test tube. We call it oil bath method. Number 5, we looked at what? Sublimation. I hope you can see. Number 5, yes, you can see. I will clean and continue. What is sublimation? Now, in the case of sublimation, when, ignore the timing of this video, it's summary, okay? I will just try and be fast so that I can compress. Now, sublimation has to do with the what? When a solid substance is heated, they change directly to their gaseous state without passing through the liquid state. That process is called what? Sublimation. Are you with me? And the substance that has undergone that process is called sublime substance. An example include ammonium chloride, NH4Cl, ammonium chloride. We also have iodine. It's an example of a sublime substance. Are you with me? We also have dry ice. Dry ice is solid CO2. It's also an example of what? Solid carbon dioxide is also an example of a sublime substance. We also have camphor. Camphor is another example. We also have naphthalene. Naphthalene. In those other videos, you can see them, but I'm just summarizing. Naphthalene. And I told you that camphor, oh, I gave this as an assignment. Okay, no problem. Camphor is the only what? Is one of the substances in the previous video I did. I gave you an example. Is the only one that can do what? Change from solid to gaseous state without heat. Without heat. But you know, sublimation has to do with what? Heating the solid substance, changing to gaseous state without passing through the liquid state. That's number 5. Number 6, distillation. Quickly, follow me with the speed of time. Number 6, if you have not subscribed to my YouTube channel, do that so that you can get more videos you can watch for both physics, chemistry, and biology. Later, we're going to do some practicals concerning this, okay? Good. You will see that in my practical section. Okay? You will see Adobe Fickenba practical. That's where you get that video. But now I've not done it. I just want to finish the theoretical part, then I go there. Now, number 6, distillation. What is distillation? Now, distillation is used to recover a solvent from a solution. Not evaporation to dryness. It is used to remove the liquid part of a mixture from a solution. That's evaporation to dryness. Distillation here is used to do what? To recover the solvent part of a mixture from a solution. It's used to recover solvent from that. That's distillation. That's number one. Then number two, distillation can be used to purify a liquid that contains non-volatile impurity. Can you see it now? It can be used to purify a liquid that contains non-volatile impurity. And I also said distillation is used to separate two or more mixtures that have what? That have large difference in their what? Boiling point. That is distillation. Okay? Two or more mixtures that have large difference in their boiling point. And I gave you an example. I think I remember alcohol and what? Water. I think alcohol and water 70 degrees Celsius, and this is 100 degrees Celsius. The other one I think I gave you ethanol and water, and I remember this is 78 degrees Celsius, and this is 100 degrees Celsius. So the truth about it is that you will see that which one will distill first out? The one with the what? Lower boiling point compared to water. So this will come out first. And then I told you when you run it through a big condenser, what will happen? With that, you can be able to what? Condense this alcohol in the other part of the container. So that's distillation, to recover a solvent from a solution, to separate liquid that contain non-volatile impurity, and to separate two or more mixtures or solvents with large difference in their boiling point. Number 7, fractional distillation. Let's move quickly. Fractional what? Distillation. What is fractional distillation? Okay, fractional distillation is used to separate two or more what? Liquids. Okay, two or more liquids with what? Close boiling points. Close boiling points. That's what you're doing with what? With fractional distillation. In this case, they have close boiling point. Or when you separate mixtures with close boiling point. And I told you, for effective fractional distillation, what will happen? What will happen is that the difference between the what? Between the mixtures must be what? Greater. Must be what? Greater than 10 degrees Celsius. It must be greater than 10 degrees Celsius. And this fractional distillation is widely employed in the where? Petroleum industry. This one is employed in gin industry. This one is widely employed in where? Petroleum industry. To separate the constituent of what? Crude oil. Okay, that's fractional crystallization. I think number 8, we look at crystallization. What is crystallization? Crystallization is used to obtain a solid from a saturated solution, or it is used to obtain pure crystals from a saturated solution. That is what crystallization is all about. The essence is to obtain salt, to have salt with what? High purity. Then the next one, number 9, we looked at fractional crystallization. Follow me with the speed of light. Fractional crystallization. If I'm too fast, I'm sorry. You can watch the video over and over. Fractional crystallization has to do with the separation of two or more salts with different solubility at different temperature. So when you separate two or more salts with different solubility at different temperature, you are carrying out fractional crystallization. The very essence of all these things is to obtain salt of higher purity. And number 10, I talked about recrystallization. Follow me with the speed of light. Recrystallization. And I said that recrystallization deals with number 10, recrystallization. I told you that recrystallization deals with the salts to be obtained, or the solid to be obtained. Okay? Recrystallization involves choosing a solvent. Listen, recrystallization involves choosing a solvent in which the salt or the solid to be obtained is soluble in it when it is what? Hot, or insoluble in it when it is what? Cold. So in recrystallization, the essence is resolution of this crystal or this solid substance to obtain salt of higher purity. So in this recrystallization, it involves choosing a solvent in which the solid to be obtained is what? Soluble in it when that solvent is hot, or insoluble in it when the solvent is what? Cold. That is all about recrystallization. I think number 11, if I can remember, number 11, we looked at, let's look at separating funnel. Separating funnel. Follow me. For separating funnel, this is used to separate immiscible liquids, liquids that do not mix. In this case, the liquid with higher density will stay below, while the liquid with a lesser density will stay at the top. So example is separation, example of what? Of fuel and water. So what will happen is that the water has higher density than fuel. So water will be found at the bottom part of the test tube or the container you're using, while this place will represent the fuel. So while here is fuel, this will be what? Water. So in this case, if you want to separate it because you want water, fuel, this is because water is what? Polar. And this one is what? Non-polar. Do you see it now? So in this case, if you want to separate them, you need a what? A separating funnel. In this separating funnel, there's a tap around this region. Now, at the end of the day, this is the container waiting. Okay? As you pour, as this top here is where you have fuel. And this down part is what? Water. So what do? You release, as the fluid begin to go down, the liquid rather, you release the tap. As the water finish dropping to the last point, what do? You shut the tap, leaving only the fuel at the region. So with that, you separated this immiscible liquid. That's separating funnel. Number 12. Let's look at number 12. The next one is what? Can you remind me? Magnetic separation. Thank you. Magnetic what? Magnetic separation. What do you do with this now? Magnetic separation is a kind of separation in which you separate magnetic substances from non-magnetic substances. Example is the separation of what? Iron filings. Yes, I remember. Iron filings and what? Sulfur. Iron filings and what? Sulfur. So when you are doing this magnetic separation, you are separating magnetic substances from non-magnetic substances. It can also be used in the separation of impurities from tin ore. So it makes your work easier. So when you do that, you are carrying out what? Magnetic separation. Number 13, we look at precipitation. Yes, precipitation. Okay, this involves obtaining a salt that has two different mixability in a solution, in a liquid that has two different mixability. That's what I mean is that precipitation deals with what? Separation of two or more salts, or separation of salts that have different solubilities in a what? In a mixable, in two or more mixable liquids, as the case may be. Now, I will explain. Precipitation deals with obtaining, okay, or separating two or more salts that have different solubility in two or more mixable liquids. So that's what precipitation is all about. So for example, alcohol and water, can you see? Let me take it up. For example, alcohol and water, follow me, they are what? Mixable. Don't forget that this alcohol and water, we separated them in where? Using, what's it called? Distillation. So they are mixable. You see, they are mixable. That's why distillation method is the best way to separate these two. Now, but I want you to know something. That alcohol, I think it's ethanol. Let's leave it to ethanol. That's the basic, the defined specific this that was used. Now, ethanol and water are what? Mixable, which is ethanol is an alcohol, so that's it. They are mixable. But let me tell you something. There is this salt, iron 2 tetrasulfate 6. Look at it here, FeSO4. Iron 2 tetrasulfate 6, listen, is soluble in water. Okay, but insoluble in alcohol. So when I mix, follow me, can you see good? When I mix iron 2 tetrasulfate 6, FeSO4 plus water, here, this is a solution of what? Iron 2 tetrasulfate 6. So iron 2 tetrasulfate 6 is soluble in water. But if I want to remove iron 2 tetrasulfate 6 out of this mixture, what do? I will bring in ethanol. So when I pour in ethanol, what happens? Iron 2 tetrasulfate 6 will precipitate, and I will now find it as an insoluble solid in this mixture. This mixture that is what? That is mixable. That's meaning that once ethanol is added, look at it now, it will now come at the top as what? Insoluble what? Solids, meaning that's the precipitate. As it comes at the insoluble solids, what happens? The alcohol will now mix with the water to form a solution. But this will now be the precipitate. How do I then remove it from this new mixture that is formed now? All I need to do is to carry out what? Either filtration. Yes, filtration is a good one because this is already out. If I pour the mixture of alcohol and water, they will go through the filter pore and come out as filtrate, leaving behind this iron 2 tetrasulfate 6 as the residue on the what? On the filter paper. If you understand, type on the comment section, clear, sir. So what I want you to do to understand is that you see this precipitation, it has to do with separating salts that have different solubility in two mixable liquids. So this liquid must be mixable first, but it has different solubility in these two different mixable liquids. In water, it is soluble. In ethanol, it is insoluble. So once I mix iron 2 tetrasulfate 6 inside water, you'll be wondering, why am I explaining this thing? Because sometimes it might be confusing. That's why I'm taking time to do that. So when you mix iron 2 tetrasulfate 6 in water, if I want to separate that iron 2 tetrasulfate 6, all I need to do is to add ethanol. Ethanol will mix with water and make iron 2 to precipitate out, which will then be separated via filtration. Do you understand that? Write copy in the comment section. Then the last but not the least, number 14. Okay, so I'm going to clean the top part so that you can follow me. I'm sorry if I'm very fast, sorry. But you can watch the video over and over. Number 14. Number 14. Let's look at number 14 is chromatography. Follow me. Chromatography. Okay, this chromatography topic, go and watch, is part 10 in chemistry. Part 10 in chemistry. Chromatography has to do with the separation of complex mixtures, okay? Chromatography has to do with the separation of complex mixtures, that's number 1. Chromatography also do with the separation of colored and colorless substance. Anything that has to do with the pigment separation, all these people that do dyeing and all that, dyeing industry, okay? Dye and dye, dyeing industry, they will carry out chromatography, okay? So, pigment separation, chlorophyll in a plant, chromatography. I'm just giving you an example. Now, what I want you to understand is that what will make this chromatography process to take place is that anytime what is to be, the solutes that is to be separated is placed on an absorbent medium, what do? They move or migrate at different speed. That is why chromatography is very, very feasible. I explained that in the previous video. So it has to do with separation of colored or colorless substances. It has to do with the separation of complex mixture. And in chromatography, we have two phases. Number 1, we have stationary phase. Okay, this is just summary. Stationary phase. Okay, just bear with me. You know what I mean there. And moving phase. I'm trying to do everything to make the video the minutes to be less. Stationary phase, the solid or the solute is absorbed. Moving phase, the solute, okay, dissolves and moves at different speed. If the stationary phase is a solid, then it simply means we call it absorption chromatography. And to obtain the constituent of this mixture, it is by distribution ratio. I've explained that in the previous video. If the stationary phase is a liquid, then we call it partition chromatography. To obtain the constituent in such mixture, it will be done by what? Coefficient of partition. Okay, I've explained that. And I also told you what we call rate of migrating, RF, which will be equals to A over B. This one means the distance moved by the solute all over the distance moved by the solvent. And I drew something for you. I told you something about chromatography. You have a structure like this. You have another. I'm just doing summary. This is lead. Around this place, solvent. Okay, here. What do you have? Solvent. Then you have a spot here. This is called a spot. So this is an example. This is a what? A paper chromatography. And let me give you examples of chromatography. Number 1, we have paper chromatography. Number 2, we have thin layer chromatography. Number 3, we have column chromatography. Number 4, can you see it? Good. Gas chromatography. And number 5, but not the least, ion exchange what? Chromatography. Okay, so this is the end of the summary of all the separation technique method. I'd like you to follow me if you're not following me. And I'd like you to write on the comment section, which do you feel you understand better? And which do you feel I should re-explain again? Okay, but if you understand everything, it's clear to you, I'd like you to write congratulations on the comment section. Thank you. See you in the next video, biology.